In the Greater Toronto Area, urban sprawl is a key issue that a lot of people are concerned about. And today we're going to be looking at how we can use multi-temporal, multi-sensor data to identify changes in urban areas. So I'm going to pass over to Sean, who's going to give us a quick demo on that. We're going to be working with some multi-temporal imagery from 2002. We have some spot data that was collected over Toronto. And then we have a series of ComSat images that were collected in 2007. So Sean's going to look at registering that imagery together and doing some analysis to identify areas of change.
Yeah, so one of the things that we're going to be doing in this demo is to show you that we're working with two different types of sensor, or data from two different types of sensors. So we have the Spot 5 data, which is from 2002, which we're looking at right now on screen. And then we have the ComSat data, which is from 2007, which is now appearing on the screen as well. So in order to, the first and utmost, or one of the most important aspects of this is to make sure that the two images properly line up with one another. So in order to do that, we actually use PCI's geoimaging tools for the Arcgis. It's an extension and you can be found in your toolbox. So we essentially have our two input images, or stack of images, which are processed or imported into the Esri environment using this module here. Now, they are all of them are inputted using a batch process, so this is all done simultaneously. We then get our inputted raw spot and ComSat images output here, and then the next stage is to collect ground control points using reference imagery and an associated digital elevation model. The next stage is to proceed on to the actual orthorectification process. So once we have our ground control points, we can then input the ground control points along with the DEM and the reference image and the input data stack in order to provide our output co-registered orthorectified image stack. Now that we have our co-registered images, we can then apply a classification of the two. Now it's very important to do a classification map for this type of change detection, because what we're trying to do is to detect where there's new urban development between 2002 and 2007. So we're looking for a very specific type of change. So the first thing to do is to do a classification of the Spot 5 dataset. So we're going to be using the interactive supervised classification tool in order to do this. Now, I have some pre-computed training sites which we've collected for this area. So I'm going to load the ones for the Spot 5. And now that we have these training sites collected, or now that we have the training sites loaded when they were previously collected, I'm just going to zoom back out here to our overview, and we can perform our classification. So we select the Spot 5 image from the drop-down list for classification, as I had just done here, give it a second to load, and then we do our interactive supervised classification using these training sites and the Spot 5 image. So once we have that, we're going to then do the exact same process for the ComSat scene. So we're going to choose our ComSat training sites, and there's a majority of those training sites are the exact same because this is an overlap area. So now that we have our ComSat training sites loaded, we choose ComSat, the ComSat scene from the drop-down list here. We can then go to our classification and once again select the interactive classification, supervised classification option. So now that we have our classification map for the ComSat scene, I'm just going to very quickly show you in our overview of the two areas where there is change using the swiping tool in the image analysis. We select the top layer that we want to perform swiping on, choose the swipe tool down here, and then we can perform a very quick visual inspection of the area. And as you can see, there's a significant difference between the urban landscape of the two scenes from 2002 and 2007. These are new subdivisions that are being put in. But now we want to document and highlight this in a final change detection map. So in order to do this, we can use raster calculator. So I'm just going to bring up the Arc toolbox. We can select spatial analyst tools, go down to map algebra, choose the raster calculator, and we can apply a set of condition statements using the two classification maps. Now we've already previously applied this, so I'm going to show you what type of map we can then generate. So now what we want to do is we want to look very quickly at the actual change and make sure that there was a high level of accuracy in the change that we were detecting. So I'm going to toggle off this urban change map, and we're going to see that in the Spot 5 image, those areas don't exist. So I'm going to just bring it back on here quickly. So if I circle my cursor here, you can see these areas, and it'll stay focused on these areas. If I turn it off, there's no urban landscape. I mean, part of the area is actually currently under development in the 2002 image. Now, if I turn off the 2002 image, we can actually see that the landscape is there. And I'm going to once again turn back on the urban change map, and we can see how we're able to accurately detect the new urban development.